Okay, here we want to look at the ratio test. The ratio is a test used for determine the absolute convergence or divergence of an infinite series. And we're going to talk about it. Now here, when you initially look at this series, you'll almost jump and make this into a geometric series. Number one, the index isn't where it should be, but the main thing is we want to use the ratio test. So now this is the ratio test. That is 5 to the 3n plus 1 over 5 to the 3n. Now, we have to remember our old rules that we learned a long time ago. No matter what, when we're doing mathematics, we never want to get too far away from the fundamentals. So remember, whenever you divide by a fraction, you still have to multiply by the reciprocal. So now, as we can see here, the 5s are just going to cancel. Now, 3 to the n over 3 to the n plus 1, that's going to give us 1/3. Let me make that a 3. Now, this answer ends up giving us 1/3. All right, 1/3 is less than 1. All right. So this series converges. All right. It converges. Absolutely. So this is how we do the ratio test. This is just a quick example. Now, another example I want to do is I want us to look at a ratio test that has a factorial involved. Okay, so let's look at this one. Let's go 4 to the n over n factorial. Okay, we want to come down. Once again, we want to let our limit, as n approaches infinity, we replace n with n plus 1. That's going to give us 4 to the n plus 1 over n plus 1 factorial. Remember, we use that instead of n factorial, over the original numbers from the series, which is 4 to the n over n factorial. Once again, remember, when we divide by a fraction, we still must multiply by the reciprocal. That's something that, once again, we've learned a long time ago, and we do not want to abandon it. Okay, now 4 to the n plus 1 divided by 4 to the n, that's going to give us 4 over 1. We remember the rules. Now, something a little bit different. N factorial divided by n plus 1 factorial, that's 1 over n plus 1. So now what we have for our answer is the limit, as we're going towards infinity, 4 over n plus 1. Now, we can remember our old rules that we've learned previously, and we don't have to go through them, but we can remember, and we go back and look at this, we'll know that this is actually approaching 0. All right, so 0 is less than 1. So once again, this series converges. So these are just two easy examples of how we want to use the ratio test. Everything is predicated on knowing our previous rules and just knowing when to use our rules and how to remember our rules, like dividing by fractions and multiplying by reciprocals, how to use things that we've learned a long time ago so that we can combine our old rules, with our new concepts.